Hello all, this is Neil from Edureka and welcome to this interesting session on Java programming. Now this session will help you get started with Java from scratch, but not only that, it will also help you in preparing on some of the key fundamental concepts that are asked in interviews mostly. So do look out for them and hope you have a great learning experience. Starting off, let's look at the agenda for this session. We'll start off by first discussing about what is variables as well as the various data types that are present in Java. Moving on from there, we'll be talking about the various operators as well as conditional statements and loops which are supported in Java as such. In the last half of this session, we'll be talking about functions as well as classes and objects, which are key important concepts with any of the programming languages, and we'll look at how it works out in Java as such. So without wasting any time, let's move forward to the first topic of the session, which is variables. Now, variables are nothing more basically than a reserved memory location to store any value that you want to use further as part of your program as such. This in turn means that every time that you wish to create a variable, you need to allocate a specific memory to it as well. Now, if you look at the statements to the left, let's not look at it in terms of a syntax. What I want to do is that I want to use three values as part of my program. I want to use 25, I want to use 3.142857, and I want to use true as well. In this case, what I would do is that I would create a variable that would store each of these values. First, I'm going to create x, which is going to store 25, y, which is going to store 3.142857, and b, which is going to store true. These in turn will get memory allocated to them, and in turn, this will also be a way for me to reference them. Now, there's two ways I can access the values that are present here. I can either go by the memory address or I can go by the name of the variable as such. So, variable name always becomes an alias as such. Before we go in deep with respect to the different types of variables that are present in Java, let's actually take a step back and let's try to understand what is the difference between a process and a program for that matter. Now, whenever you write a set of codes, it basically is going to be combined together to form a program as such. Programs are usually stored on our secondary memory like our hard disk and executed whenever needed. A running instance of a program is always referred to as a process, and a process mostly works on your primary memory like RAM. So in short, you can say when a process is created, the program gets memory allocated to it as well. But what happens in the memory? So memory can be again segmented into two regions, which is stack and heap. These are actually nothing more than names that are given to the memory segments as such. Now let's say I create a primitive variable. Now again, there are two types of variables that you need to always look out for: primitive variable and reference variable for that matter. Now if I'm using a primitive variable, let's say I am creating int I here. Okay, now don't go by what is int, we'll be talking about it a little later. It basically is a data type. For now, just remember it's how you create a variable for that fact. Now if I say int I, or let's take a more realistic scenario, let's say I am taking someone's mobile number. Let's say I'm going to declare int phone number, then correspondingly what happens is that memory gets allocated from the stack region to this phone number variable as well. And this is about 4 bytes of memory. Now we'll be talking about the standard memory allocations also going further, but just get this idea in your head. Now anytime that I want to access the values that are stored here, I can either go by the memory address or I can go by the variable name that I'm going to be using, which is phone number for that matter. Now coming to the second type, which is a reference type. Reference type can be your strings, which is basically a collection of various characters, or it can be an object of a class as well. Now, not going into the details as such, let's take a real world example. Let's say I want to take the address of someone. So what happens is that the address cannot always be fixed to a constant. Yes, I can keep a maximum limit for it, but it idealistically does not seem right for me to do that as well. So let's say I'm going to create a string, say address here. It becomes a reference variable. Now, what do I mean by that is that it takes a variable size for that fact. Now, you cannot decide the size of a string. So it means that string address here is a reference of a string type, okay, which in turn can actually hold a string of various values for that fact. Whenever you're going to assign a value to the address, let's say I want to write Edureka unit 501 Bangalore 66, then what would happen is that the value that I provide would be stored in heap, and there would be a corresponding reference variable, which is my address, being stored in the stack. So every time I wish to pull the information, I would go to the stack, I would check the string, and then I would correspondingly take it up as well. Now this is a very important understanding, and usually this is something that is always asked in an interview, whether you understand the difference between a stack and a heap, and when do you use a stack, when do you use a heap as well. Some of the times they do ask you a difference between a primitive variable and a reference variable as well. So I hope you guys are clear with this. Moving on with this, let's talk about the different data types that are supported by Java. Now, what is a data type? Basically, it's a means through which I can classify these variables. Now, why do I want to classify them as well? Because we will be using these variables for some future operations as such. Now, if I use a character for addition, that does not make any sense. There's no point in me adding a plus b unless a and b actually store some values in turn. Okay, now, if I just use the alphabet A and I add it to alphabet B, then that is not a valid operation for that fact as well. And when I use addition with respect to characters, it's a totally different sense as well. So classification is a very important part of the variable system in any programming language, and that's done through the data types associated to the variables as well. Now, if you look at here, I'm using three variables here, and each of them belong to a different type. Now 25, which basically is a whole number, belongs to the class of integers, which is why I write int x is equal to 25. Same, I have y is equal to 3.142857. So there's a decimal point value. So I'm going to be using a floating point variable, or I'm going to just specify float here. Finally, b is going to store true. So I know it's either going to be true or false. So I can go with a Boolean data type as well. So let's actually move forward and look at some of the most basic data types that are supported by Java. There are mainly four different types of data types which are present in Java. You have integer, you have float, you have character, and you have Boolean. Apart from this, there are going to be user-defined data types which you'll be seeing in our later sessions as well. So just make sure that you understand these four because we'll be going into them one by one. Let's start with integer. As I said, integer is used to store whole numbers. Now, again, in integer, they can be classified into four different types. I have byte, I have short, I have int, and I have log. Why do I need to have so many different types? Mainly, this is where your memory management concept also comes into picture as such. Now, on a short run, definitely it does not make a difference for me to use either of them. But when you want to write optimal and long code for your programs, then this does make a difference because memory management in itself also is essential factor for defining how fast your program executes. Because even when you look at a basic level, your primitive data types perform much faster than your reference data type as well. So again, memory management is a key factor. If an application takes too much memory, it may not run. If it requires too much storage memory as well, then again that might be another challenge as well. So again, these are some of the key factors that you always need to keep in mind when you want to write real optimal programs as such. Now, talking about each one of them, a byte can actually store any value that is between -128 to +127. Now, as the name suggests, it can take 1 byte of memory as well. Now, when I come down to short actually can store from -32,768 to +32,767. Again, this is a standard range that has been defined, and for integer, it starts from 2,147,483,648 to 2,147,483,647. Again, with respect to long, it's even further as such. So the greater the number is, the more memory it would take, and the corresponding data type would also be assigned. By default, if you're using a whole number, it is assigned to the integer type as such. Now, if you want to make your code more optimal, then you can go with short or byte depending on the number itself. Again, byte, as I said, takes 1 byte, short takes about 2 bytes, int takes 4 bytes, and long takes 8 bytes of memory as such. Next data type is your floating data type. So again, these are used to store numerical values along with their decimal point or fractional point values as such. Again, there are two types of floating variables present here. You have float and you have double. So again, the precision is what makes a difference here, and by default, it's always double. And if you look at the data type, your float takes 4 bytes and double takes 8 bytes of memory as such. Moving forward, you have character data types. Characters are usually stored to similar to your character values. These can be alphabet, these can also be numerical values, this can also be symbols for that matter as well. Okay, so everything that you can see on your keyboard can in turn be represented using a single character for that matter. Now again, a character data is usually about a 16-bit Unicode character. So as I said, a 16-bit again translates to roughly 2 bytes of memory as such. So the range for a character idealistically starts from 0 and goes all the way up to 65,535 if you want to store a numeric value as such. The only difference that you might see between a character value and the short data type is that here you cannot store negative values, but in short you can go with the negative values as such. Now finally you have Boolean data type, and Boolean, as the name suggests, would either stick to true or false and is usually used as a flag to check condition statements. And as you might have assumed, a Boolean usually takes just 1 byte of memory for that matter. Now enough of theory, let's actually try to understand all these with an example, and I'll be using Eclipse IDE for this matter. Now let me give you a heads up, I've already set up Java 9 on my system, and I've also set up Eclipse on my machine. Now Eclipse is an IDE that I prefer with respect to writing codes in Java, but you can have different preferences as well. There are a lot of professionals who like to write their codes on the console itself, but again my recommendation is that if you're starting off with a programming language, it's better that you start off with an IDE because there's a lot of support and help that comes with respect to it. So we'll be looking at each one of them also on a small level. So let me go back to my Eclipse and let me show you how to start by creating a new project, and let's also start with our codes. Now this is my Eclipse environment. Let's first begin by creating a new Java project. So you see the new option present here and just click on Java project option. Now you need to name your project. So let me call it Java programming for the session. And once you've done with that, if you've set up your environment, make sure you choose the correct environment. Now, as I said, I have set up Java 9 on my machine, so I'm going to with Java SC9. And once I've done with this, I'm just going to click on finish, and automatically my Java project has been created. If you expand this, you can already find two entries present here. One is the JRE system libraries and the source folder. Now, click on the source folder and select new option, under which click on class option. Now everything that you write in Java is part of a class. So he will be starting by creating a class called hello, which is the first program that you will be writing as part of this. Apart from this, make sure that you click on public static void main because it automatically creates a main function for you. Now in terms of execution, always the execution starts from the main function. So this is something that you need to remember while you're writing programs. Now let's start with the most fundamental program that you would be writing on any programming language, which is hello world. Now in order to print anything on Java, you need to write the following command, which is system.out.println. Now one shortcut for that on Eclipse is that just write sysout and press Ctrl and space. This in turn will expand it and you will get the complete syntax present here. Now I just specify hello world here, which has to be printed. And in order to run it, you have the run option present here. So just click on run and it will ask me save and launch option. So once I click on OK, automatically, as you can see here, the result is also out. So you have successfully executed your first program. Now let's leave this aside. Let me just remove this. Now in order to create a variable, as we have discussed, you need to start by specifying the data type. So I'm going to create an integer variable, let's say num1. And let's say if I don't want to initialize its value at this point, I'll just put a semicolon here. So one thing that's important with Java is that you need to make sure your indentation and semicolons are always right. So if you want to keep your indentation right, Control Shift F automatically does that for you. Now apart from this, let's say if you want to initialize this value, num1 equal to 100. This is just an initialization that I have done. Same thing can also be iterated, and it can also be done in one single step where I remove this, and while I'm declaring the variable itself, I can assign a value to it. So I know that num1 should have 100, so I can do this as well. Now let's say if you want to create a variable of float type. So float flt1 colon, I'll create one of double as well, dbl, let's say character. So it's up to you how you want to create. I'll also create a Boolean one. I've created 5 different variables of different data types as well. Now again, if you want to print any of the variables to identify their value, just use system.out.println and specify which value do you want to print. Now at this point, I have initialized only num1. Okay, so when I print num1, then automatically you can see it's going to give me a value of 100. But to those of you who are coming from a different programming background like C or C++, you must be aware that every time a variable is declared that they are given a garbage value as such. So let's see if that's the same with Java as such. So I'm going to replace this. I'm going to print the floating variable that I have declared. Now, one good advantage of an IDE like Eclipse is that it already tells you that there's an error present here. It says local variable flt1 may not have been initialized. But still, let me try running this. When I try running this, there's also an error that says there is an existing error with the project. Do you want to still continue with the execution? I click on proceed, and you can see it has compiled and given me the following error that the variable flt1 is not initialized. So this is one good advantage. So let's say if you're going on a console and writing the same code, then what happens is that you would only get the compile time error that happens. So on an IDE, it's slightly easier with respect to that same, where when you write the syntax itself, it identifies the errors that are present. So small issues like errors or semicolons can always be avoided for that matter. Now, if I had initialized value to FLT1, then it might have printed this, but let's try that as well. So let's say if I do FLT1 and equal to, let's give it a value of 13.145, and I just place semicolon here. Okay, I'm still getting an error. Do you know why this is? This is because of the default data type that has been set for floating point variables. Now, if you go on top of the error, what it's going to tell you is that it's a type mismatch, cannot convert from double to float. So as I said, any decimal pointed value by default is considered to be of a type double here. So if you wish to make convert it to float, you can either put an F here, okay, which will automatically solve this issue, or the other way around is to specify the type that you want to convert before it. If I put a parenthesis here and I say float, then the issue also gets resolved. So this is a process called typecasting. Now to understand this, let's go back to our slides and let me give you an idea with respect to that same. Now typecasting basically is an operation done to provide more memory or reduce the memory usage by the variables as such. Now this also helps you to keep a standardization with respect to that same. So let's say if I'm trying to store a large value in a variable which cannot be stored, automatically the machine identifies this and promotes this, which is known as implicit casting or implicit promotion. Now if you look at the diagram here, you can see how the implicit promotion happens. A byte can be converted to short, which can in turn be converted to int. Character also can be directly converted to integer values as well, because these occupy more memory, thereby enabling you to convert int to long. Long then again can be converted to float, and finally double because it takes the maximum size. Now what I have done here is that I have specified to convert float to double as well. Now let's try something more interesting. Let's leave this aside. Let me create a variable of type long. Okay, long, let's say num2 equal to 200 for this matter. Okay, now let's say I want to update the value of num1. Num1 equal to num1 plus num2. Now what you need to understand is that this is not wrong in terms of mathematical expression, because always the expression to the right is first computed and then stored into the variable on the left. Okay, now if I put a semicolon here, there is still an error. Do you want to guess why? This is because the system has automatically promoted num1, which is used here for addition, to type long. Okay, and what are you trying to do here? You're going to add two numbers of long type and then store it inside an integer value. Now if the same thing, if I put it inside a parenthesis and I specify that it has to be converted to integer type before being stored on the num1 variable, then the error gets resolved. As you can see, the numbers are getting added and then stored inside the variable num1. Okay, this is something that is quite interesting, and it's also important in terms of an interview perspective as well. Till here we've talked about variables, the different types of variables, we've talked about different types of memories, we've talked about data types, we've talked about typecasting as well. So these are key concepts that you need to remember, and you need to be strong when you're talking about fundamentals of Java. Now let's try something interesting. Let's look at an example of implicit typecasting itself. So let's say for ch1, I'm going to assign the value of the character small a. Okay, and now what I'm going to do is that I'm going to give num1 the same value as ch. Okay, if I put a semicolon here, you may notice that there's no error, because we had seen the hierarchy earlier. We had seen that characters can be converted to integers, but is this a right operation? So let's actually see this through the example, which is, so let me print ch here as well, and let me also print num1 here. Okay, and I'll just save this and let me just run this. Now you can see here, although it is printing ch as a, but when I'm trying to print num1, which is having the same value as ch, it's giving me the output of 97. Can you guess why this is happening? This is mainly because when you're converting it from character to integer, it is taking the ASCII value of the character. Now each character or symbol that we use has a corresponding ASCII value, and that is what is actually being converted and stored in an integer variable for that matter. Let's try another example. Let's say I'm going to declare another variable. Let's say I'm going to create another variable ch1 and I'm going to assign the value while it's being created. I'll assign it I. Okay, so I've created a variable ch1 and I've assigned it the value of I. Same, let me go on to create a third variable. Let's say char c2 is equal to, let me try adding these values, ch plus ch1. Okay, put a semicolon here and you can see there's already an error that's showing me. What it's trying to tell me is that I cannot convert into char. So automatically it has promoted it to a character. Again, this is something that can be solved by typecasting. So if I've converted to character, then the issue gets resolved here. So as you can see, there's no issue here. And if I try to print C2 here, then something interesting would come out from this. Let me save this and let's try to run this. As you can see here, it's giving me a total different character here. It's just added the integer value of a and small I. It's done that by taking their ASCII values and then reconverted it back to a character, which is what you're seeing on the screen at the moment. So this is something interesting because this is sort of an example that you would see with typecasting as well. Now let's take something interesting. Let's try something different. Let me just go on to clear all this. Okay, I'll just clear these statements as well. I'm going to go on to create a variable of type byte, which is the smallest integer type variable that you've seen, right? I'll call it B. I'll assign it a value of, let's say, 100. Any issues here? No, right? What if I add another 0 here? Then you can see it's already giving me an error that says type mismatch converting from int to byte. It's already identified this value to go beyond a byte and it's by default taking it to be an integer variable as well. Now let me reduce this. I'll make it just 10 and I'll perform a multiplication operation here. B is equal to B star B. Put a semicolon here and again there's an issue. Now if you notice, I'm just multiplying 10 into 10. Again, this is a byte value that is being multiplied, which is going to give me a result of 100. But it's also giving me an error that type mismatch has occurred from int to byte. This is mainly because of a concept or a phenomena known as type promotion. So let me talk about type promotion as well, because this is also another important concept with respect to Java programming. Now, there are mainly 4 rules that are followed in case of type promotion, and this is something that really makes you admire of how smart the Java virtual machine is. Now, by default, characters do get converted to int. A byte can be converted to short, then int, then long, float, and double as well. Now, all byte and short values by default are going to be promoted to int for that matter. And if one operand of the entire expression is long, then the entire expression is considered to be long. If one operand of the entire expression is float, then again it's completely float. And if one of the operands is actually double, then the result also is going to be double for that matter. Now, if you look at our case, what is happening is that byte is getting promoted to integer. So integer and integer is going to give me an integer value, which is going to be stored in a byte format. So if I just put byte here and perform typecasting, then it's perfectly right. If you print B here, then you're getting the answer to be 100 as well. So this is something that's quite interesting and definitely should be aware of with your interviews as well. So typecasting and type promotions are some of the key fundamental concepts to look out for. Now coming back to our presentation, let's move on and talk about the different operators which are present in Java. Before that, let's talk about what is an operator. Now operator basically are constructs or symbols which help you manipulate the values stored in a variable or operands for that matter. What is an operand? Anything that you wish to operate on. Okay, there are 4 different types of operators which are present in Java. You have arithmetic operators, relational operators, unary operators, and logical operators. Let's look at them one by one. First comes arithmetic operators. Arithmetic operators are quite similar to your standard operations like addition, subtraction, multiplication. And to those of you who are extremely new to programming language, we have a concept of modulus present here. Now, like in a normal division wherein you perform a division and you get the quotient as the answer, in a modulus division, what happens is instead of a quotient, you get the remainder as the output for this matter. Now, when you talk about relational operators, you have equal to, not equal to, greater than, less than, greater than equal to, and not equal to. Double equal to is always used to compare. Now, relational operators mainly are used in conditional statements, which we'll be discussing further, and usually are something that are used to check the relation present between the two operands for that matter. Then you have unary operators. Now, unary operators are something of my favorite and is something that's always a tricky question for that matter. Now, unary operators are basically of two types. Here you are just working on a single operand and there can only be two operations that you can perform. Either you increase the value or you decrease the value. And the increase and decrease is by a value of 1. Now, when does the increase or decrease happen? Either I perform an increase before I go on to do any other operation which is pre-increment, or I perform the operation I want and then I increment the value that is needed. So let's take an example to understand this. Let me write it down for you here. Let's say I have a variable called I. Okay, now I'm going to define an expression that says I plus 1. So this is my standard expression. Okay, now if I perform plus I, okay, and this is a unary operation, and then I add 1 to it. And if I perform I plus and 1. So these two are not going to give me the same answer but different answers. Now in this case, let's say I assume the value of I to be 2. Okay, in the first operation the answer is actually going to be 4. Now what is happening is that first I'm going to increment the value of I, which is what pre-increment does. I'll increment it, then I'll perform the operation. So I'll increment the value from 2 to 3, then to that I'll add 1. In the second case, what happens is I'll take the present value of 2, then I'll perform the operation. After the operation is complete, I will increment the value of I. So the result of the second one would be 3 instead of 4. Same with case of decrement. You either decrement before the operation starts or decrement after the operation is complete. Let's try to understand this with an interesting example. Let me go back to my Eclipse. Let me clear all this. Let's say int num equal to 5. Okay, so I'm just declaring a variable called num, and I'll also create int answer, which is going to be equal to plus num plus num plus num plus. Okay, so I'm performing a pre-increment, a post-increment, and a pre-increment, adding all of them and then printing the answer. Okay, now I'll print two things. Let me first print the value of num. Okay, so I'll print the value of num, and I'll also print the value of the answer as well. Okay, first let's try to understand what is the value of num at any point. Okay, now let me put this in comments so that you can understand better. Single line comments can always be used with double backslashes, and this is one of the best practices to use. Always make sure you have good readability with your code and you are commenting in your code as well, because although you may be writing the code today, tomorrow if anyone wishes to read the code or get an understanding from the same without comments, it might be quite hard for them to get a complete idea as well. Now what is going to be the value of num here? Okay, I've defined the value of num at the start. Okay, now what I'm going to do is that I'm going to update the value because I'm performing a pre-increment. So 5 becomes 6. Then to this, what I'm going to do is that I'm going to perform a post increment operation. So the value remains 6 itself, which will get updated after this. And then I'm going to perform another pre-increment. So what is happening here is that the value is taken as 6 and then the value gets updated. So here I have 7, and finally there's also one more update that gets added. So 6 plus 6 becomes 12 plus 7, which becomes 19. So let me just run this. And as you can see, the answer is 19. And after this, the value of num finally becomes 8 because I have one last post increment. I hope you guys have got a good understanding of pre-increment and post-increment as well. Now let's go back to our presentation and let's talk about the last type of operators, which is your logical operators. Now again, there are three types of logical operator. You have logical AND, logical NOT, and logical OR. Now logical NOT is the easiest of all to understand. That is, if a value is true, then logical NOT converts it to false. So it basically just flips the value with respect to that same. When you come down to logical AND, Here what happens is it will return the value of A if the value of A is assumed to be false. Otherwise it will return the value of B. Now logical OR is actually quite opposite of this. It will return the value of B if B is false, otherwise it will return the value of A. Now although it might seem quite complicated, when we talk about conditional statements and loop statements, you might get a better understanding of that same. Now let's move on and talk about conditional statements, and we'll be talking about the first conditional statement, which is an if statement. Now if statement is quite straightforward and easy to understand. That is, if and certain expression is true, then execute a set of statements which are present inside it. Now if you look at the flow as well, okay, you start off your operation and then you go into the if condition statement. If it is found to be true, if the specific expression is true, then what would happen is any code mentioned inside this branch would get executed. If not, this code gets skipped. But what if I have more than one condition? What will you do in such cases? Then you have your else if condition. So else if actually lets me write multiple conditions that needs to be evaluated. So if my first condition is not true, then it will go and check the next condition. Again, if it is found to be false, then it will not execute. Now, if I have multiple conditions, then I can always have a ladder of if else if situation, wherein I'm validating all the conditions. Now, there will also be operations where you would need to perform some set of operations or some set of statements. If none of the statements are true, then you would go on to execute the else state. Now, in order to help you understand this, let's look at it with an example for that matter. Now, in order to help you understand, I've already written a sample code present here. So what I'm trying to do here is that I'm trying to assess what are the number of digits that are present in a number that I'm passing. So what happens is that I'm defining a value of a number equal to 25,000. Okay, then I'm writing my nested condition. So this is how you represent an AND operation in Java. Okay, so first I'm checking if the number is less than 100 and if it is greater than 10. So only and only if both of them are true will it enter this condition. That's how your logical AND works. Now, unless and until both the values are true, you would not get a true value for this expression and you would not execute the following sequence. But whereas in case of your logical OR, what happens is if either one of the conditions are true, it will give you an output of true, which will in turn enter the statements that are present inside. Now, here I'm using logical AND because a two-digit number falls in this range. Okay, it starts from 10 and goes on all the way till 99. So this is the range that I have defined. If it is in this range, then it is a two digit. If it is greater than 100 but less than 1000, it's a three digit. If it's greater than 1000 and less than 10,000, greater than or equal to 10,000 and less than 1 lakh, it's a 5-digit number. Okay, so this is the range I have defined. If it is not falling in any of these categories, then I'm going to say that this number is actually not between 1 and 99,000. That is, it's beyond the range that you have specified. Okay, now let me just run this program, and if I click on OK, as you can see, it's telling me it's a 4-digit number. So I had just reduced 1 0. So let me add 2 zeros and let's rerun this, and you can see it does not follow in this range. So what we've understood here is that we've seen how an if-else ladder being executed, as well as I hope you got a simple understanding of how the logical AND operator is also being used. Now let's come back and let's talk about the next type of conditional statements, which is a switch case statement. A switch case is quite similar to your if-else statement. The only difference between an if-else statement and a switch case is that here you actually know the value based on which you have to evaluate. Now, in my previous example, I did not know if the number fell in between the range of 10 to 100, 100 to 1000, 1000 to 10,000 and 10,000 to 1 lakh. But when you know the exact value which it can take, that's when you would actually be using a switch case statement. Now, ideally, if you look at the flow of a switch case statement, it's not quite different. It's just a little more structured. You start off by switching into the expression, and then you check if it's the first value, second value, third value, or fourth value. If it's none of the values, then you reach the default state. Now your default case is very much similar to your else statement. Okay, now if a value is matched, then the corresponding statement is written and then you break out from the sequence of operation. Now break is something that's quite important as part of a switch case statement. So let me just give you an example and help you understand. Let me go back to my Eclipse and show you the code. So again, to make it easy for you to understand, I've already written a code here, and what I've done here is that I have defined the value of day equal to 4, and then based on the value that I want, I would correspondingly be creating the different cases. Now I know the days start from 1 and goes all the way till 7 for a week. Now in this case, if it's any value beyond that, I know it's an invalid day as well. Now if you can see here, my week starts with Sunday, Monday, Tuesday, Wednesday, Thursday, Friday and Saturday. Let's just run this. Now as you can see, the value that is getting printed is Wednesday, and if you check here, it's for case 4. Now what would happen if I remove break statement from here? Let me remove break statements from all the consecutive cases that are present. Okay, now I'm removed break statement from here, and let me just rerun this. Now if you notice, what is happening here is that every corresponding value or every corresponding case which is present after the required value gets executed if break is not present. So this is something that you need to be careful about while you are working with switch case statements for that matter. So let me come back and let's move on to the next interesting topic, which I like the most, is loops. Loops are basically those statements which actually help you execute same set of statements multiple number of times. Now if I want to perform one continuous operation of addition 5 times, then rather than writing it 5 times, I would just put it inside a loop. A loop helps me execute a set of statements multiple number of times. Now in Java, there are mainly 3 types of loop. You have a do while, a while and a for loop. But before we talk about them, let's just look at a general flow of a loop statement. You always start, then you go on to check the condition of the loop. If it is found to be true, then what you do is that you execute all the sequence or the statements that are present inside it. From there, you go on to check back the condition, and again, if it's found to be true, you're going to keep repeating for the same. Unless and until your condition is not found to be false, you do not exit from that loop. Once you've done that, then you go on to the next set of statements which are present. Now let's talk about one by one. Let's start with a do while loop. A do while loop again is one of the most basic statements, but is slightly different from your loops. This is called an exit control loop. Here, instead of checking the expression first and then executing the statements, it's after you execute the statements that you check the condition. So let's just look at the flow to get a better understanding. You start off with the operation, you enter into the do sequence, and then you execute the block. Once you execute it, you reach the while condition where you check the condition for that matter. If it is false, then you exit from that loop. But if it is true, you go on to repeat it. Now, one thing that you need to understand is that a do while loop is used in situations where I need to execute the statements at least once. So the minimum number of execution of the statements present inside the loop would be at least once. Now let's look at an example to understand do while loop for that matter. Let me create a new class file and let's begin with the do while loop. Okay, so what am I going to use do while? So let's say I want to add all the first 100 numbers which are present. So I'm going to create an int num equal to, let's say 1. Okay, so from 1 to 100, and I'm also going to create another variable called sum. Okay, now I'm going to write a do while loop. Now inside this, let's say sum is equal to sum plus num. Okay, now I don't want to write this, I want to reduce my code length. So in this case, what I'm going to do is that I'm going to remove this entire process and I'm going to write plus equal to num. So this is a shorthand writing. Okay, so this in turn is equal to sum is equal to sum plus num. Okay, so I've just reduced the entire operation and it's quite fast for that matter. While, now I want to write the while statement. So let's say while my num is less than or equal to 100. Okay, but I need to again increment the value of num. So for that, what I'm going to do, I'm going to go back into the loop and I'm going to use one of my favorite or interesting operator, which is the Unary operator, num plus plus. So every time this value has to get incremented. So once this is done, I'm going to use sysout and I'm going to print the value of the sum. Alright, well and good. Now for just clarification, I'll just initialize it as 0 and let's begin executing this. So you can see the sum of the first 100 numbers is 550. Okay, now this is just one way of doing this. Now the same can be done slightly easier when you look at the next loop statement that we're going to be talking about, which is the while loop for this matter. Now a while loop basically repeats same set of operations, but the major difference between a do while and a while loop is that here you actually check the condition before you enter into the sequence, or if before you execute the statements. So you start off, then you go on to check the condition. If it is false, you exit from the loop. If it is true, you execute the block and then go on to check the condition till it's found false. Let me come here, let me reduce this entire process. Okay, let me remove this, let me make it as a while loop, while. Okay, now in this case, what I'm going to do is that I'm going to change the value of num from 1 to 100. Okay, and while num is greater than or equal to 1. In this case, perform this operation, but not on an increment level, but on a decrement level. That is, keep decrementing the value till you get the answer. So what is going to happen is that it will come into the loop first. It will see the value of num is equal to 100. It will go into it. It will add from 100. Then it will reduce the value to 99. It's going to go back and it's going to keep checking the same. So again, this seems a little more apt for the sequence that I have mentioned. So let's run this and the answer remains the same. It's just that I've taken a different approach to solve the same problem for that matter. Now, the last kind of loop statements that we'll be discussing is the for loop. Now, for loop is again something that you use in case where you know that the number of iterations needed is fixed. So let's say if I know I need to execute a statement 100 times or 10 times for that matter, that's when I'll actually be using a for loop. This is what makes it different compared to the while and do while loop. But on a same level, a for loop is also an entry control loop. You only check the condition and then go on to enter the statements that are present inside. So it's similar to the while loop, but it's used when you do know the number of iterations required. So again, the previous statement can again be made it quite easier. But before that, let's start off by understanding how the for loop works. You start off with an initialization step. Now the syntax for loop is also slightly different. You have three different elements present here apart from just the expression. You have an initialization, you have a condition, and then you have an iteration. Initialization is just to keep a track so that you remember how many times you need to execute the set of statements. Condition is for checking the condition, and iteration is to increase the initialized value so that the repetition takes place as per required. Once initialization is done, I'm going to check the condition. If it is false, I'll exit from the loop. If it is true, I'll execute the statement. Then I'll perform an iteration on the initialized value and I'm going to keep repeating the same. So this is going to execute n number of times with respect to that same. Now, if the same statement has to be converted into a for loop, let me just remove all this. Let's say for int I. So I'm already declaring a variable here equal to 0. I less than equal to 100, and I'm going to perform the iteration here itself, I plus plus. Now inside the loop, what I'm going to do is that I'm going to write sum plus equal to I. Okay, this is my statement. Now this in turn helps me eliminate the need for another variable called num, so I'm just going to remove num as well. And if I run the same statement, I get the same answer for that matter. So again, this is how you can use three different ways to solve just one simple problem. The ideal difference is that you need to have a clear-cut understanding of when to use a while loop, when to use a do while loop, and when to use a for loop. My suggestion would be is that you remember what is the purpose of each of the loops. You use a do while loop when you want to execute the statement at least once and then decide whether to continue or not. A while and a for loop are used when you want to first check the condition and then decide whether to execute the statement or not. A while loop is used in cases where you're not sure of the number of iterations, and a for loop is used in situations where you exactly know the number of iterations required as well. Is that clear? Please make sure that you have some clarity with respect to that same. Now, before we go on and get into the details, I just wanted to show you something interesting that I always loved and helped me understand loops concept quite interestingly. There was a song called 99 Beers on the Wall. So a lot over the years, one of the key interesting things that loops helped us understand was to write the lyrics using the for loop statement. So here's a slightly different version of what you would find on the internet. Now, I know there are certain things that you have not been interested to. So let me just show you an example with respect to that. Ideally, the lyrics goes 99 bottles of beer on the wall, one bottle of beer, take it down and pass it around. and it keeps getting reduced as it keeps going on. So you need to count down with respect to that same. So I first start off by initializing the number of beers to be 99, okay, and then I define the words to be bottles. So this is how you define a string. You specify the type string and then you use the name of the string, following which the value as well. Then what I'm going to do is that I'm going to use a while loop where the number of beers are greater than 0. I'm going to check if the total number of beers is equal to 1. If it is 1, then I would replace it with bottle. Now what I'm going to do here is that I'm going to start by printing my number of bottles. So it's 99 bottles. Okay, then what I'm going to do is that I'm going to use a plus symbol. Now a plus symbol here is used for an operation known as concatenation. Concatenation basically is used when you want to join two strings or two words for that matter. Now again, strings is something that we'll be extensively discussing on in our upcoming session. So I just wanted to introduce and show you how interesting this would be when you look at it and get an idea of the loop statements as well. So I'm going to tell the number of beers that are present at the moment. I'm going to add a space between that. Then what I'm going to do is that I'm going to use the word bottles. Okay, this will in turn tell me how many bottles are present on the wall. Then what I'm going to do is that I'm going to say the number of bottles on the wall, and I'm going to specify these are the number of bottles of beer. Then I'm going to say take one down and pass it around. So this basically is telling me that I need to reduce the number of beers by 1. I can do either this or I can just write beer num minus minus. So this is two ways that I can write the same. Okay. Now finally when it comes down and I find that the total number of beers at this point is 0, then I'm going to say no more bottles of beer on the wall. That means this is my end. So this is how I'm going to execute it. So let me just run this and let me help you understand how this works out. Now let me just go up, let me just show you this. Now if you see, let's start from the first. 99 bottles of beer on the wall, 99 bottles of beer. You take one down and you pass it around. So I have 98 bottles of beer on the wall, which is 98 bottles of beer. Again, I take one and I keep passing it down. Now this goes all the way down, all the way till I realize that I have taken out my last bottle and I have passed it around, which lets me know no more bottles of beer on the wall, and it automatically exits as well. So this is roughly about 500 lines of output, which has been generated from what I would say. Let me remove these white line spaces as well. So roughly in about 20 lines of code, I have created a program that gives me about 400 lines of output, just using mainly the logic of loop statements. So this is just one interesting example that I loved with respect to loops, and I usually use for explaining the loops concepts as well. So now let's move on and talk about functions, which is another interesting concept of Java. Now again, functions basically is a block of reusable code which actually can be used to perform a single and a related operation any number of times that you want. Okay, now again, functions can be of two types. It can be a predefined function or a user defined functions as well. Now when we talk about predefined functions, your main is a predefined function where your execution starts from. Your system.out.println is one of the best example of a predefined function as well. Now what you're seeing here is just a function that will help you add. So let's just look at it in Java. Okay, so this is the same function that I have shown you in the representation there. What I've done here is that, let me explain the code. I've declared two variables, num1 and num2. Okay, then going on, I have created a new variable called answer. Okay, and let's just leave this part out for now. Okay, and then I'm just printing the answer here. Now before we go on, let me explain here. So this is what you would refer to as a function call, and this is your function definition. Okay, so once I call a function, then it automatically goes down and checks where the function has been defined. Now it finds that the function sum has been defined here, and then it goes, the control moves here before it executes the next set of operation. So what happens first is that a variable num1 is created and memory is allocated with, and the value 10 is stored inside that. Same is repeated for num2 where the value 35 is stored. And then what is happening is that I have found a function call. So I'm going to go to the function definition. Now if you see the function definition, then what you can see is that it takes two values as an input. So these are the parameters for the function. Now you can have parameterized function or non-parameterized function as well. Now in this case, I'm saying that it needs to take two values as the parameter. Okay, once it's taken two values, I'm just going to create a new variable called solution, and I'm going to add these two numbers. Once it's added, then what I'm going to do is that I'm going to return this value back to the place where it is being called. Now, this is to help you understand the overall flow. So this is where the sequence starts. It goes down to the function definition. It executes the function definition and then goes back to where the function was called. Now, once it returns here, what it's going to do is that it is going to assign the value that I've got from solution into answer. Once that is done, then it's going to print out the same. Now, it's a very basic program, but I hope it will give you an understanding of how functions work. Now, if you execute this, you can see the solution as the sum of the two numbers is 45. So let me just summarize what has happened. I've created two variables, then I've called for the function, the control has moved to the function, and once the function operation has been completed, which is an addition, it goes back here and it works out. Now again, I've already defined two numbers here, but let's say I have to calculate something more interesting. So idealistically, functions are used mostly when you're using a user defined value, or when you want to perform a same set of operations for a different set of values as well. So this is when you use functions. Remember, there's a key difference between loops and functions. Loops gets executed either indefinite number of times or finite definite number of times, but you do not need to call for that loop execution. Once the loop execution starts, it'll keep going on until it's completed, and then it'll move on to next lines of code. Whereas in a function, every time I call the function, the control moves on to the function definition as such. Okay, now let me help you understand how to write Fibonacci series using functions in Java. Okay, so I've already written the Fibonacci code here, so let's just look at it. So what I'm first doing is that I'm globally defining the values of variable n1, number 1, number 2, and number 3. So 0, 1, 0 is what I'm going to follow here. Okay, then I've defined a function called printFibo, which is going to take the count. Okay, if the count is greater than 0, then what it is going to do is that it is going to add number 1 and number 2 to and store it inside number 3. Okay, then number 1 gets replaced by number 2. Number 2 gets replaced by number 3. So this is the sequence that you always follow with Fibonacci series. Alright, so in this case, what I'm going to do is that I'm going to print only the first 10 values. So I'm always going to print number 3 here. Okay, and this is to keep track with respect to that same. Now, finally, what is going to happen is that it is going to call the function itself. So it's going to be a recursive function. So a function calling itself is always referred to as a recursive function for that matter. So this is something that is quite interesting with Fibonacci series and this example for that matter. Okay, so let me just show you the main as well. So in main, what I've defined is that I've defined the count to be 10. So I just want the first 10. So let's say I want the first 25 numbers of the Fibonacci series. So first I have to print number 1 and 2 because I'm always going to start by printing number 3. Okay, so 1 and 2 are 0 and 1. That's how your Fibonacci series starts. And I'm going to pass my count minus 2. That is my present count minus 2 because inside the loop it's subtracting by 1. So let me just execute this and let me just rerun this. So as you can see, it has given me the first 25 values of the Fibonacci series, and I hope this has given you an insight on how functions work. Okay, so let's go back to our presentation and let's talk about the final and one of the most interesting concepts of Java, which is classes and objects. Now, to those of you who heard of object-oriented programming, the concept of class and object is not something new. Classes and objects have been the core foundation of the object-oriented concepts. Now, according to the OOPS, there are mainly 4 things that belong inside a class: a state, an attribute, a behavior, and a method. So to define a class, you have to define these 4 things according to the object-oriented theory. Now, since we are in Java, if you want to create state and attribute inside a class, you have to define a variable, and for behavior and methods, we'll be creating functions or methods for that matter. Now, let's first begin by creating a simple class called car. And slowly we'll be talking about the different concepts of car and I'll help you understand how it works. Now, to help you understand what I've done here is I've just created a skeleton of 2 classes present in the same file. I also have a class called useCar. Okay, inside which my main is defined, but there's nothing written inside that. And what I've done is that I have saved it by the name of the class which has my main function. Now let me just show you what happens when you compile a Java code which contains multiple classes. In order to compile a Java code, always use the command javac followed by the name of the file. Now I have only one file present here, so I can execute this. But before that, let me just show you the number of files that are present here. So dir actually tells me that there's only one file present in this location. Okay, now what I'm going to do is that I'm going to use javac, following which I'll specify the name of the file and I'm going to click on enter. So now here, let's just try to see what DI is giving me. It tells me that there are two class files that have been created here. One is of car.class and other is user car.class. Okay. Now if you check the root folder also, as you can see, there are three files present here. Car.class, user car.class and user car.java. So user car.java was the code that we had written. Now the bytecode is created according to the classes. Now even if we have two classes, it will create two bytecode files, one for the car and one for the use car as well. Now let's see how we can create objects for the car class. So let me go back to my Eclipse, and here what I'll do is let me create a new class. Let me call it use demo, and I'll include main as well. Now before I get into use demo itself, let me also create another class demo here. And inside this, let's say I'm going to create a new variable called val. Okay, I'll come back inside my use demo and I'll remove this. Now let me create something known as an object of the class. Now objects are nothing but an instance of a class as well. Like how you had a process being an instance of the program, objects are an instance of a class. So how are they different? Let's take the example of cars itself. Whatever I design with respect to a car, okay, a car has to have four wheels, a car has to have two headlights, a car has to have a windshield, a car usually is driven by one person, so a single steering wheel. All these are basic parameters that I can define for a car. But when it comes down to an implementation, then what happens is it slightly varies. Now a car can have a color, but as you can see, there are various colors that are available with respect to cars that are out there today. Okay, coming in terms of the wheel thickness, coming in terms of the brand that is being developing. So an Audi A6 will be as much as different from a BMW or an Mercedes S350. Okay, so each one has its unique attribute, but end of the day, we all refer to them as cars itself. So my cars here becomes my class, and each of these vehicles themselves become an object as well. Now, in order to understand how to define an object of a class, all you need to do is first specify the class to which the object is going to belong to. In this case, it's going to belong to the class demo. Then what I'm going to do is that I'm going to create an object. So specify the name of the object obj, then use the keyword new. Now new here is used to allocate memory for that object. Okay, and finally we're going to use something called constructor here, which we'll be talking about in our next sessions. While creating an object, if you wish to initialize a value, then you use something called as a constructor. By default, every class has a constructor, so we're going to call the default constructor, which goes by the name of the class as well, which is demo in this case. Okay, so once I do this, the object is going to get created. Now if I wish to have a unique value for an object, then what I can do is that specify the object dot I have val. Okay, and then what I'm going to do is that I'm going to assign it a unique value, which is 19,000. Okay, so this is just a rough value for that car. Okay, I have created an object, I have assigned a value for that as well, but the question is, how do I access it, or how do I make use of it? So what you need to understand here is that demo obj, or what you're seeing, the obj in itself, actually is a reference to the class. Now it means that class actually is a referenced user defined data type, and this in turn means that we can create reference variables of type class demo. Now these in turn are also capable to hold references of the class demo objects as well. Now let's try to access this value. Now same command that I'm going to use, but there's a slight difference with respect to it. Now let's say the value is, now again make sure these are in quotes, because if not it would not get printed. Now following this, put a plus. As I said, plus here is for concatenation or joining two strings or values. Now in order to access it, you cannot directly type value. Now if I type value, it would tell me there's no variable which is going by the name value. Now if you see here, it tells me value cannot be resolved into a variable. But if I say obj.value, then it says no error. This is again because obj here becomes a reference of the type demo. Okay, this is what I have been trying to explain earlier. Now in here, if I just execute this, then you can see the value is 19,000 as I have defined it as well. Now let's actually go back to the most important question here, that is, what is an object in Java and how is it created? Now let's go back to the syntax that's present here. What we've written here is demo obj equal to new demo. This statement actually creates the object for the class demo in the heap region. So this is how objects are created. Now, what if I just write this statement? I remove demo.obj and I just write new demo. Okay. Now, what happens here is that it creates an object which returns the object reference, and it is captured by the obj, which in turn is the object reference as well. So if I do not specify this, then it does not have a reference point. Now, this statement in itself is also known as anonymous object creation. Okay. A class is used for code organization. Now, what you need to understand is the more I want to bring structure into my code, the more I'm going to break it down, the more I'm going to introduce newer concepts, I'm going to introduce functionalities, and class is one of the best example for code organization. Now, if you actually look at the structure inside a class, we can create variables as well as methods inside them. Now, remember, methods or functions in themselves cannot be outside the class, because as we've known, Java is a language where everything needs to be inside a class. But then a class in itself is also existing inside a container known as package. So for variables and functions, we have a container which is class, and for classes, we have a bigger container which is a package, which in turn is actually stored as a folder in your system. Okay, now if you look at the example here, you can see that I have various classes created, but they are all present inside a specific package called default package. Now I've not named this. If I want, I can name this as well as per my requirement as such. So a collection of all these classes will in turn be in a folder called a package. Now I can also have various packages present inside a package as well, depending on my requirement. Now ideally this is the hierarchy that you would be following in a project as well, wherein you would be working with multiple variables, which in turn will be working with multiple functions, which will be present in multiple classes. Again, these classes will be inside packages, and packages themselves will be working hand in hand with each other as well. Quite fascinating, right? That's the interesting part of Java. Now, moving on forward, let's actually look at how accesses to these classes can be specified. That is, what exactly is the access for a class, and from where is it accessible in Java, who can access it, and how can it be accessed as well. Now, when you talk about the access specifier for a class, there are mainly two types of access specifier. First is default. Now, as you can see, there is no keyword that is present here. You don't need to write anything as such. It's understood that is default. Okay. Let's look at the example of class demo itself. This is a class that is of the type default. But what you need to understand is that this class demo is actually accessible only inside the package in which it is defined and not outside this. The second and the last type of access that is present with respect to classes is public access. Now, this access with respect to class provides access to the class within the package as well as outside as well. Now, although this is very interesting and useful, there is only one restriction with respect to public access. Now, let me go back to my previous example. Let's take the same use car. Okay, let me just open this in a notepad. Now, if you see here, I have class car, I have class use car as well. Now, I have not defined anything with respect to that same. Now, let's say if I make this public, then, and if I try to compile this, let's see what happens. Now, as you can see, there's already an error that tells me that it should be declared as the file name car.java. Okay, so this is one of the first and most essential mistake that is happening. Now, as per this rule, that whichever class is public in that file, you should save the name of the file with the name of the class which holds public with respect to it. Now, one more thing that ideally is recommended while you're going with respect to programming in multiple classes is that the class which contains the main function should always be the public class as well. This is because main function is where the execution starts, and that is one place that has to be public as well. You might be wondering, why is this needed? Why do I actually need to name only one class as public, as well as I need to have the name of the file as the public class? Now, what you need to understand is that although on a small level, while you're working with one or two programs, this may not seem as a problem. But when you're working on an organizational level, let's say you're working on a very huge project. Okay, Java in itself follows a RAD model. Now, here what happens is you have to make a lot of classes while you're working on a big time project as well. Now, let's say I'm taking a class which is designed by John. Okay, now inside, if the rule was not present, One of the first things that you would be noticing is that there are multiple classes present. Let's say I have A, B, C, D, E, F, G classes present. Now, if I'm searching through the source code, now this becomes a challenge as well. And even in the folder, it's being stored as my.java as well. So this does not give me any clarity with respect to which is the main function which can be accessed, and it becomes a problem as well since it has multiple public functions as such. So Java in itself has brought a restriction in JVM that the file name and the class name should be the same, and this in turn is the code organization principle. Now let's look at the access rules for the class members which are present. By default, there are 4 different accesses that are associated with class members. Those members which are private can be accessed only within the class and cannot cross the class boundary as well. Second, you have default. Within the class, these variables can be accessed, as well as when you bring in the concept of inheritance, even the child class can actually access these variables as well. Second, you have default. Default helps you to access every variable that is of default type within the class, as well as any child class that is part of the same package as well in which it is defined. So let's say I have a package called package1 inside which I'm defining int x, and this is of a type default. I have class C1 and child class C2 as well. So X in turn will be accessible in child class C2 also because it's been defined in class C1 as such. Okay, so again, what you need to understand is those variables which are part of the same package, if they belong to default, they can be accessed without a problem by any child class part of the same package as well. Now, let's say you want to access the member outside the class, then this can be done by an object reference, but it needs to be within the same package in which it is defined. So anything in class, let's go back to the same example. I have a function that is present inside class C1, and if I want to call that function in my child class C2, then I can do that by using an object reference provided they both are in the same package as well. So third, you have protected. Now protected is an evolved version of default. Using protected, the members can actually be accessed by a child class which is also present in a different package provided it is doing the same using an object reference. So let's say I have a child class C3 which is present in package 2, which is the child class of C1. Okay. Now if I have an object reference, then I can call any protected member that is present in class C1. Fourth and finally, you have public. Again, this gives you complete access for you to access these variables. Now by default, it's always recommended that you do not keep any variable public because it becomes openly accessible as well. Now, in order to help you understand what I have discussed till here better, let's actually go back to my Eclipse and let's try to understand. Now, in order to provide protected access to any variable, it's not very hard. All you need to write is protected. Okay, and automatically the variable becomes protected in nature. Okay, so if you go over it, you can actually find it is of protected nature as well. Now let's try to look at an example where I'm going to comment this out. Now what I'm doing here is that I'm not giving an initial value to my object reference. Okay, now if you've noticed earlier we had gotten an error. Okay, earlier when we were using a variable, you had to initialize it. But let's test this out and let's see what happens. As you can see here, the value is 0. Now what JVM has done is that it has set a rule that whenever a variable is declared in a class, then JVM automatically initializes these variables with a default value while it's creating an object. Now these default values have already been fixed. That is, they're already set in the system for each of the data types. Now let's see in case of other variables. Let me add double, dval. Let me add a Boolean, bval. Let me also give a character, cval. Okay, so what I'm just doing is that I'm just declaring these variables as part of the class. Now let me just copy this up. Okay, so I'm going to print the double value, the Boolean value, and the character value as well. So let me just save this and let's run this. Now you can see by default for a double it is 0.0, for Boolean it is false, and for character it's a single white space that has been stored as well. Now it's very important for any interview that you understand how we can create methods inside a class and the syntax as well with respect to that. Now first, and the most important is the access specifier and the return type, then the name of the function as well as the parameters. Same like how we had done in case of a function. Now here we had specified the access specifier. Now I had not come on this earlier because I didn't want to confuse you guys. So by default my sum function was public. Okay, then I'm going to specify the return type. Okay, now it's of a return type integer. This is also has been specified. Now let's go back and now again, in case of your access specifiers, what you can do is these can also be public. If you do not specify anything, it will be default. You can also keep them protected and even private as well as for your requirement. Again, as we had explained earlier, once a function is called, then you go on to find the definition, you execute it, and then you go back to the caller once you've successfully executed it as well. Now here one important factor is that you need to understand there is a function call that is maintained and it's in a call stack internally. Let's say I have four functions. A has called B, B has called C, C has called D. Then after you finish D, it reaches to C, then C gets executed, reaches to B, and B gets executed, finally comes to A. Now let's actually see how this is done with a demo. Now if you look at our operation in itself, there's always a first function that gets called, that is your main function. So this is my entry point and this is always the first function that gets executed as well. Now if I come down here, let's say I'm going to create a new class here. What I'll do is that I'll remove the sum function from here and I'll put it inside a new class as well. Let me just modify this to help you understand. So I hope you guys have understood this function. I'll bring my function here and I'll just remove this. I'll just keep it void. That is, it's not going to return anything. Now I'll just remove the values that it is taking as well. So it's not a parameterized function. And what I'm going to do is that I'm going to define num1 comma num2 here. Let's say I'll say num1 equal to 190, num2 is equal to 109. My solution is also going to change. It is going to be num1 plus num2. Now instead of returning this value, I'll just copy this, I'll remove it from here and I'll put it inside the sum function itself. Okay, so what I've done is that I've just modified my previous function to add to a two class system wherein I'm going to define one more. Let's say this is a function that is going to return a value in sum1 and I'm going to start defining this. I'll just copy these two lines and I'll make sure this answer is returned. Okay, Control Shift F actually formats it, so that's a very useful code in this case. Now if you come down to my main, now what I'll start off is, let me remove this entire process. So let me begin by creating an object reference to my function class. Function obj, again this is an object reference, equal to, use the new keyword, and then the constructor as I had mentioned. So let's begin by calling the sum functions, obj dot sum and obj dot sum1. Now this in turn actually is how you make use of methods in a reusable environment, and it should have a better design as well with respect to that same. Now one thing that you might notice here is that even though the object is returning a value present in sum1, it's not throwing me an error at this point as well. So this is something that's quite interesting with respect to memory management as well. But when we talk about memory management, the first question that actually comes to your mind, or that should come to your mind, is that does a function actually take any memory? So we've actually discussed that a class has two members, one for member variables and second for functions. So we know if we create the class, then we can also create the class members also. So let's actually see when they are actually created and they come into memory, or when are they actually allocated memory so that we can use it. So let's see when they are available. So when we create a variable, it gets memory when the object for that class has been created. For accessing them, we require the object reference. So it uses or fetches it and you get the object reference. For every object, there is a separate copy of member variable present in the memory. That is, if we create 10 objects, then 10 copies will be created for each and every variable that is present as part of the class. And when we talk about functions, they come into memory when the class is actually initialized in the memory. When class is initialized, only then do they get memory allocation. Now, the only difference between functions and member variables and objects for that matter, is that when they actually come into memory, there's only one copy of the function that is stored in memory. And every variable or object in turn is going to access this same copy of the function present in the memory itself. Now, again, if you wish to access these functions that are present in the memory, you need to go back to your object references as well. Now let's take another example to help you understand how this is. So let me come back to this program. Okay, so I have a class called car inside which I've defined price. I've also defined a function called show price, which I'm not using at the moment. Okay, I have a public class called use cars, and I have a main function present inside that. Here what I'm doing is that I'm creating an object of the class car and I'm setting the price equal to 1000. Now I'm directly printing this. Although this is not wrong for me to do that, what you need to understand is that we want this output to be printed by the function in itself. Because we've already learned a rule that members having default access specified can be accessed within class anywhere. So what I'll do is I'll just modify this code. I'll change this print statement from here. I'll cut it out. I'll go inside the member function and I'll just print price. But instead of the object reference, I'll just directly print price. Okay, so this is not at all wrong. Now, in order to make sure that this is going to be printed, I need the object reference obj.showPrice. But there is one more problem, that member variables come in memory when object is actually created. And when we have to use them, we require an object reference. But here what I'm doing is that I'm not using an object reference first. So first, let's actually see whether this code will run or not. As you can see, it is printing the answer, which is 1000. The price is 1000. Now that this has successfully executed, this in turn actually means whatever we have discussed till here is actually wrong. Let's actually analyze this and understand what JVM is doing internally. Now we are executing the program and the definition of the car class is loaded into memory. Now in memory, a copy of show price also gets created. You're creating an object whose reference is with the obj, and you've passed obj which had the value of 1000. Now this 1000 was again given to value as well, and then what you did was you called obj.showPrice. Now let's actually break this down. Now in this case, what has happened is that I've used only one object. Let's say I have multiple objects, obj1 and obj2. obj1 has price 1000, obj2 has price 2000. Now when you call show price, it is only referring to price which is present there. Now, how is the machine supposed to understand that this is for which obj? Okay, so here what is happening is that there's only one copy, but ob and obj have different copies as well. So how do you actually recognize which price does it denote? Is it ob's price or is it ob1's price? Now, the second problem that you can see here is that it is directly accessing price without an object reference as well. So how will it recognize which object is calling which one? Now, in order to overcome all these challenges, JVM actually introduced a very interesting concept, which is the this keyword. The this keyword holds the current class object reference in the function, and this reference is automatically present inside the JVM, and till the point that you're performing any operation inside the function, this automatically is activated. Now, in order to make our code slightly better, let me just modify this code a bit more. Okay, I'll update it here. Let's say sysout and copy this statement and change this to this dot price. Okay, now it is telling me that this is the price for the object. Let me also try creating another object and updating the value for price as such. Okay, I'll have two objects and let's see what happens. Alright, so what I've done here is that I've created a new object reference, and using that I have given a value for price. Now let me just execute this and let's run this and see how it works out. Now since I'm calling it with obj1, the price is 1000 and it's for the same object that is showing 1000. Let me try for obj1 and it's updating with respect to that same as well. So this is actually a very important keyword that is being used and helps you keep tracks of which object is working with respect to the members. Now with this we actually come to a conclusion, and we've discussed some of the major topics as part of this session. We started off by talking about variables. We talked about the different types of variables. We talked about the concept of typecasting as well. We talked about the various data types. And then moving on from there, we talked about the various conditional statements, the loop statements, we talked about functions, and then we had an in detailed walk into classes, objects, and even the this keyword as well. So these are some of the interesting and important concepts related to Java programming. So with this, we come to a conclusion. Hope you have a great day. Thank you and goodbye.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!